So 5.3, we're going to start with multiplying this problem. So negative 7n squared means negative 7 times n squared, and this means 6 times n cubed. So as you get more proficient at this, you don't have to break this apart every time. You can go more directly towards your answer. But we can rearrange this as negative 7 times 6 times n to the second times n to the third. Remember, multiplication is commutative, so if all of this is multiplying, then we can rearrange it. So negative times positive is negative. 7 times 6 is 42. And when we multiply things at the same base, we add the exponents. So 2 plus 3 is 5, so n to the fifth. So that's the first one. Not necessarily number 1, but that's the first example. And a lot of this section is about the distributive property, and we hinted at the distributive property in the last video that we did. So in this problem, in the parentheses, we have a trinomial. Remember, that means we have 3 terms. So if we have something in front of that sitting there, the understood operation is multiplying. So whatever we have here gets multiplied times that whole parenthesis. However many terms we have, that's how many things that piece out front is going to be distributed to. So for that x squared, we're going to distribute a negative 2x times that x squared. And then we're going to add whatever we get when we take that negative 2x and distribute it to the 6x. And then we're going to add whatever we get when we take the negative 2x times the minus 9. Keep in mind, this sign goes with a 9, so it's all of this times negative 9. And there are a couple different ways to write this, but this lets us see what are we distributing and what is it going to. Distributing and what to. So when these are multiplied together, we have negative 2 times 1, so negative 2. And when we multiply our x's, x to the first times x squared, remember we add our exponents. So we get x cubed. Here we have a negative times a positive, which is a negative. 2 times 6 is 12. X times x is x to the second. Of course, you could rearrange that if you need to. Put the numbers together, put the letters together, but still that makes negative 12. That makes x squared. Here we have negative 2 times negative 9. Negative times negative makes a positive, 18. And then we have an x, and that one doesn't have an x. So 18 is times x. Notice these are not like terms because each term has a different exponent, so that's as far as we can go with it. So we have multiplied each of these pieces by a negative 2x. This is another problem with distributing, but notice on this one we have more than one term out front. If we just simply had a 17, we would distribute 17 times that, and we would do 17 times that. Or if we just had y, we would do y times that and y times that. So what we're really going to do is both of those. We're going to do y times 3y and we're going to add y times 1. And then to that, we're going to add whatever we got for this distribution. 17 times 3y plus 17 times 1. So however many terms we started with here, the first term gets distributed to that second parenthesis, y times 3y and a 1, and 17 gets distributed to the 3y and to the 1. Now we just need to perform these operations and combine like terms. So here we have a understood 1 times 3. So 1 times 3 is 3, and a y and a y. which of course is y squared. Here, y times 1, well, anything times 1 is itself. Here we have 17 times 3, which is 51, times y. And then on the end, we have 17 times 1. This time we do have like terms. The middle two terms are both y's to the first. When we're multiplying, remember we do not have to have the same exponents, but when we are adding or subtracting, these do have to have the same exponent. We have 1y here and 51 of those here. So regardless of what the fact that this is a y, you could think of it as an apple. If I have one apple and I get 51 more apples, what I have are apples. 1 and 51 more makes 52. So that's how many apples. We have y squared. Well, y squareds are different than y's, so remember we can't combine those. We have to leave them separate and then bring down our 17. Now the next one is very similar to the last one, but I chose this one because this one has fractions, which automatically give people hives and rashes and fevers and make people nervous and afraid and things. So the process is the same. We just have to deal with adding or multiplying or subtracting fractions along the way. So we're going to take the x and we're going to distribute it to both pieces in the second parenthesis. So we're going to do x times x, and we're going to do x times negative 2/3. Then we're going to do 1/3 times x, and we're going to do 1/3 times negative 2/3. So x times x is x to the second. Positive times negative is negative, and x times 2/3 is the same as 2/3 times x. Positive times positive is positive, 1/3 times x. Positive times negative is negative, and remember how we multiply fractions, we go straight across. So 1 times 2 is 2. On bottom, 3 times 3 is 9. We happen to have the same denominator, but we only have to have the same denominators when we're adding or subtracting. If we're multiplying, we just multiply the tops, multiply the bottoms. Now we have to combine like terms. So this is the only x squared term, so bring it down. Both of these terms have x's to the first. So we combine their coefficients, and we want to see what is minus 2/3 plus 1/3. Fortunately, these have the same denominator, so we don't have to get a common denominator. So remember, the way we add and subtract fractions is if they have the same denominator, keep the denominator and put the numerators together. So negative 2 plus 1, opposite signs we subtract, take the sign of the bigger number. So negative 1/3 is the coefficient of x. Bring down the minus 2, 9. None of those are like terms. This term has x to the second, that has x to a different power, and then that term doesn't have an x. So none of those are alike, so just leave it like it is. Now the next one we have to be careful with. It's easy to mess this one up. As I grade test, this problem is a common problem that's missed because in the last section we saw that when we had a product and it's raised to a power, each factor got that exponent. 2 got the exponent and y got the exponent. But that's only true if we have a product or a quotient inside that parenthesis. If we have a polynomial, that doesn't work. So if we have terms, we have to omit the shortcut and do it the long way. So what is the long way? Well, we have a base, and it's raised to a power, so we write the base however many times the power tells us. The power says write that base twice. Now we have to distribute it. X gets distributed to 8x, 8x also gets distributed to 7. Then this 7 gets distributed, so it gets distributed to 8x. That one gets distributed to the 7 also. So some people remember that as FOIL, first, outer, inner, last. But FOIL only works if it's 2 terms times 2 terms. I just remember it as distribute. Take the first term here, distribute it to the second parentheses. Take the first term, or the second term here, distribute it to the second parentheses. So that'll work regardless of how many terms we have. So here, if we were to rearrange this, we would have 8 times 8, x times x, 64, x to the second. Here we would have 8 times 7 times x, so 56x. 7 times 8 is another 56x, and then we have 49 on the end. The like terms that we have are the middle two, so if we combine those, we add their coefficients. So when we add those to get 112, so that's how many x's there are. So we have a total of 64x squared, 112 x's, and then 49. So the biggest thing here, don't try to do the shortcut. Don't try to do 8x squared plus 7 squared. It does contain that, but it also contains more. So have to be careful there. It's just another distributing problem. Notice we have a trinomial here, and we're distributing 5x. Out front we have one term because there's nothing added to the 5x, so all of that is one term. So we distribute 5x times 4x squared, and then we distribute 5x times minus 3x, and then we distribute 5x times 3. So 5 times 4 is 20. X times x squared. What do we do with those exponents? And we add them, so 1 plus 2, so 20x cubed. Here we have a positive times a negative, which is negative. 5 times 3 is 15. X times x is x to the second. And here a positive times a positive is positive. 5 times 3 times x will make that 15x. No like terms, so that's our final answer. This one is similar to that last one, but notice in front we have this parenthesis, and in front of that parenthesis we have not just one term, but we have two different terms. How do we go with two terms? Terms are either added or subtracted. Here we have one thing subtracted. So when we do that, we take each term in the first parenthesis and distribute it. X times minus 2x, x times 5. And then we do minus 3 times each one. So minus 3 times x squared, minus 3 times minus 2x, minus 3 times positive 5. Now we distribute them. Now we multiply and combine like terms. Add the exponent. Positive times negative is negative, and we have a 2 times x, so that's 2x to the second. Positive times positive is positive. X times 5, or 5x. Positive times negative is negative. Negative times positive is negative, so negative 3x to the second. Here we have a negative times a negative, and then times an x. So negative times negative is positive, 6x. And then we have a negative times a positive, which is negative. So like terms combined, we have only one x cubed term. Then these two terms are x squared. So we have minus 2 of those and minus 3. So that would be minus 5. So we've taken care of those. Notice often I'll check things out just so that I know which terms I've accounted for. So we've taken care of this one. We've taken care of combining those. Now 5x and 6x, we add 5 plus 6. And that's how many x's. So we've done those. The only term we haven't checked off is the minus 15. Nothing is like it, so bring it down. So now we've distributed and combined like terms. Now here's kind of a little application problem or a geometry problem, and they ask us for the area. Remember, to get the area of a rectangle, that is length times width. So the length of this rectangle is 6x plus 5 yards. The width of this rectangle is 7x minus 5. I might have said 6x, but 7x plus 5 and then 7x minus 5. Let's talk about our units. If we're multiplying a length of yards times a width of yards, yards times yards, those are the same. So that would be yards to the second, or square yards. So it's probably going to ask you for the units, or yards times yards is square yards. When we're looking for an area, typically that's going to be square units. So now we just need to multiply this out, so we have to distribute. 7x times 7x. 7 times 7 is 49. X times x is x to the second. 7x times that one. Positive times negative is negative. 7 times 5 is 35x. Now we distribute this one. So 5 times 7x. 5 times 7 is 35 times x. And 5 times negative 5. Positive times negative is negative. 5 times 5 is 25. Now we just need to combine like terms. Notice the middle terms are alike and they're opposites. We have positive 35 and negative 35. Well, 35 minus 35 is 0, so those cancel. So our final expression is that our area is 49x squared minus 25, and the area to that is square yards. Or the units, I'm sorry, to that is square yards. Now we have one more problem, and for this problem, it has 4 parts. It asks us to add these, subtract them, multiply, and divide. So let's begin by adding them. Let's do negative 3y to the 5th plus 18y to the 4th. Now, how do we add these? This is y to the 5th, this is y to the 4th. Those have different exponents. If we have different exponents, we're not allowed to combine those by adding or subtracting. So that's as far as we can go with it. Well, let's subtract them. So let's do the first one and subtract the second one. Well, the same rule is true for subtracting. If we have different powers, these are not like terms, and we can't subtract them either. So that's as far as we can go with that one. No simplifying can be done. What about multiplying? Can we multiply these? Do we have to have like terms to multiply? Well, no, we don't have to have like terms to multiply. all of this stuff is multiplied together, so we can rearrange it. We do have some things that are a little bit alike. These two are both numbers, so we can multiply them. Negative times positive is negative. And if you multiply those together, you would get 54. These had the same base. What do we do when we multiply and our bases are the same? We add the exponents. So our exponent would come out to be 9. But this exercise is to remind us, when do we add exponents, when do we not add exponents, when can we not put things together. So when we're multiplying, if we have the same letters, yes, we can do that. We just add the exponents. If we're adding or subtracting and we have different exponents, we can't do that. So let's do dividing. We can reduce this. 3 and 18 have a common factor of 3. 3 goes into 3 once. 3 goes into 18 6 times. So our coefficient on top is -1. Our coefficient on bottom is 6. And then what do we do, or can we divide if these have different exponents? Well, we can divide them and we subtract the exponents. Essentially, we have this one and this one both have at least 4 y's, so we can cancel out how many they have in common. If we cancel out 4, all of those are gone. If we cancel out 4 here, we started with 5 and we're taking away 4. Notice we're just subtracting those exponents. 5 minus 4 is 1, so we're left with y to the first power on top, or we could just write this as -y/6. So that's what we would get if we were to divide those.